And so this video goes along with evaluating functions, okay? So first thing we want to do is go over what the goals are for this set of notes here. We want to describe the input as the independent variable. That's going to be x. So anytime you hear input, you think independent variable, you think x. Those always go together, okay? Output, dependent variable, y, okay? And today what we're going to work on is evaluating a linear function for a value of x and using function notation to do that. So we're going to introduce you to f of x today, okay? So the independent variable, okay, is the input of a function, okay? For our purposes, more often than not, the independent variable will be the x coordinate for the functions we're working with, okay? The dependent variable is the output of a function, okay? For our purposes, that dependent variable is usually going to be y. Now, the independent variable can be something other than x. The dependent variable can be something other than y, but for the most part, we're going to be dealing with x and y for independent and dependent variables respectively. Okay, so function notation. All right, so this is the first time you guys have seen this probably. If x is the independent variable and y is the dependent variable, then the function notation for y is what we call f of x. Okay, we read that f of x. Okay, so this f parentheses x here, we're going to read that as f of x. So it's a function of x is going to give us the same thing as y. So y is f of x. What that means is anytime you see y, you can interchange that with f of x and vice versa, okay? So we say the dependent variable, y, is a function of the independent variable. So y is a function of x, okay? So y is a function of x, or y is equal to f of x. And again, that makes these interchangeable, okay? So functions kind of work like machines, all right? So we're going to input a value. In this case, we're just going to say x. You could input any value. You could input any variable. You could input any expression, okay? But if we input x into this machine, and then we multiply it by 3, and then we subtract it by 5, the output, okay, whatever comes out of the machine is going to be y, or f of x, okay? So using this machine, it creates this equation, y the output equals 3 times the input minus 5. So that's what this machine creates, okay, this equation, all right? So we want to evaluate this equation for different values. So let's say x equals 0. So we're going to input 0 into our machine here, into our function, and that gives us y equals 3 times 0 minus 5. Okay, we just replaced x with 0. So now we want to use order of operations. 3 times 0 is 0, and then 0 minus 5 will give us our output of negative 5. So when we evaluate this function, okay, this equation for a value of x equals 0, we get an output of negative 5, okay? Let's evaluate that same function for the next two values, for positive 2, okay? If we substitute 2 in for x, we get 3 times 2 minus 5, okay, which simplifies to 6 minus 5. So an input of 2 into this equation gives us an output of positive 1, okay? And then the last one here on this example problem, let's input a negative value, negative 5. So we're going to input negative 5 where x was, okay? We're going to multiply and then subtract, okay? So we get negative 15 minus 5. Now we subtract and we get negative 20, okay? So that's evaluating an equation here, a linear equation, y equals 3x minus 5 for these three different values. Okay, pause the video here and let's try to evaluate this equation, this linear function here, for these three values of x, okay? All right, so we're going to plug in 0 again. We're going to substitute 0 into our linear function here, okay? We're going to multiply negative 4 times 0, which gives us 0, and then we add 1, and we get y equals positive 1. So an input value of 0 for the independent variable gives us an output value of 1 for the dependent variable, okay? So you can see again that y depends on x. The value for y always depends on what we plug in for the value of x, okay? Let's plug in x equals 2 this time, all right? We're going to multiply negative 4 times 2, which gives us negative 8. And now we want to combine negative 8 and positive 1 here, and that gives us negative 7, okay? And then see, if x equals negative 5, we want to plug that in. So we've got a negative 4 times a negative 5, which is positive 20, okay? And then add 20 and 1, and that gives us an output value of positive 21, okay? Well, we're going to use function notation instead of y. So notice before we had y equals some algebraic expression over here that contained x, all right? Now before we said y and f of x were interchangeable, that they were the same thing, okay? So we can replace y with f of x, okay, and this is called function notation. So we read this, the function of x is equal to 2x minus 1, okay? And we want to evaluate that for f of 3. So what this tells us is this value 3 here is going to be replacing, the x value, okay? So it's basically doing the exact same thing, it's just giving you a different type of notation, okay? So let's do problem A here. Let's find f of 3. So what is the function's output when the input is 3, okay? So 3 is going to be the input, f of 3 is going to be the output, okay? So f of 3 then, all that means is we're going to replace x with this value 3 here. So we've got 2 times 3 minus 1, which is 6 minus 1. So f of 3, 3 being the input, gives us an output of 5, okay? So 3 and 5 would be the input and the output, the independent variable and the dependent variable, the x coordinate and the y coordinate, okay? Let's try B, and then I'm going to let you guys pause the video and try the last 3. So in B, we're going to find f of 3, okay? So we're going to replace x with 3. We're going to multiply 7 times 3, that gives us 21. We add 4, so we get 25, okay? So the input is 3, the output is 25, okay? So pause the video here and try the last 3. Find f of 3 for each of these 3 functions. Okay. All right, so let's do C. We've got f of x equals 1/3 x plus 5, and we want to find f of 3 again. So again, we're replacing x with 3. Okay, we want to multiply 1/3 times 3 is positive 1, and then 1 plus 5 would give us 6. Okay, so an input of 3 gives us an output of 6. If we plugged in a different value for 3, then we'd get a different output for f of x, or in this case, f of whatever that value would be. Okay. D here, this is what we call a quadratic function because we've got an exponent of 2 here. That's the largest exponent. So we want to evaluate that function for f of 3. We're going to replace x with 3. Order of operations, we have to square the 3 first. That gives us 9 plus 11, which combines to be 20. Okay. So in this quadratic function, if we input 3, our output is positive 20. Okay. And finally, evaluating this quadratic function for 3, we got 2 different x's here. So we're going to have to plug in 3 for both of those spots. Okay? So I've got 2 times 3 squared plus 4 times 3 minus 9. All right, so order of operations, I have to square this 3 here first. So that's going to be 2 times 9. 4 times 3, I multiply and get 12. And then I've got my minus 9 here. Okay, order of operations, I have to do multiplication first. So it's going to be 18 plus 12 minus 9. And then I can just go from left to right. So 18 plus 12 is 30. 30 minus 9 is 21. So when I input 3 into this function for both of these values, my output, my dependent variable, my y coordinate will be 21. Okay, and that's how you evaluate functions in basic linear form and in function form.